Hello, welcome to Physics 116 here at the College of Staten Island, otherwise known as Physics 1. This is lecture 1 of Physics 116, and I'm really glad that you're here. Thank you so much for being part of this course. This first lecture does have material in it that you need to fill in for homework, so get started on writing those lecture notes, okay? Start taking notes now. Go ahead. If you need to pause for a second, pause, and then go and get something to write with. Yep, go ahead. Okay, you're back. All right, here's the deal. This lecture, we're going to do quickly and get you introduced and started on the course, and then there will be other stuff happening. In all, there are 24 lectures, and they are all video lectures, and they're all kind of done like this, okay, pretty much. There's not very high production value. We don't have the budget for it, sorry, but it's a conversation. It's an outline. It's the core of what we're doing here and trying to knit together all the things that we're doing in the course of this term. Okay, that is what you're going to be basing your course off of. But this course, as all courses should be in the 21st century, right, uses not just a person talking into a microphone in front of a camera or in front of an audience in a lecture hall or something like that, right, but actually uses all, or at least many, of the resources that are available to us in the 21st century, because that's what you're doing, right? What is physics after all? It is a way to use and quantify the laws of nature so that we can make our lives better, right? That is what physics is all about. Getting a little bit ahead of myself, but let me draw on that a little bit more as we talk forward. Okay, here's the basic plan. This class, right, contains a lab component and a lecture component, right? Now, what does that mean? The lab component means you are in the classroom actually doing stuff, right? This is very important. Why? I mean, it's reasonably obvious. If you want to be good at something, you just got to practice it, right? There's no way you can do it other than just actually doing some stuff. I mean, the goats, think about like Michael Jordan or LeBron James or, whomever that you admire in sports, right? These guys go and shoot free throws and take jump shots and do drills every day, right? They don't just go out and miraculously perform perfectly every time. They practice, they work hard, right? Even the greatest home run hitters in baseball, they take batting practice all the time, right? The greatest musicians, they practice hours and hours every day. You see them for a few minutes and you see them perform and you're like, wow, they're amazing. They didn't just get there, they actually had to do stuff. So the lab part is crucial, right? It is essential for you to be exercising different parts of your life, of your learning. The lecture part is also important, but it's important a different way. So that's why the lab part and the lecture part will not always exactly align, but it's all part of the same process of learning. Right? You're going to hear me say this often, many times. You're going to learn in different ways when you use different techniques and different materials. So my lectures here, they're important in knitting together the ideas of the science, okay? It's not going to be just a repeat of whatever materials you can look up on the internet, right? In fact, we're going to be using the internet a lot. Let me tell you right now what we're going to use on the internet a fair bit and other things too, so that you know, okay? This is the 21st century. We're going to use lots of different things. I might not have the budget to make a high quality presentation with lots of bells and whistles and cool stuff, but there are people who do, and they have very graciously shared their material with us online free of charge, so we're going to use them, okay? So let's introduce ourselves to that stuff right away. I'm going to share my screen right now, and we'll start talking about those things for just a moment, okay? And then we'll get back to them a little bit later. All right, so the main textbook for this class is this openstacks.org college physics textbook. Okay, here's the URL here. You can look it up, you can find it. Basically, these authors, okay, Professor Urone and Dr. Hinrichs, Dr. Urone at Cal State Sacramento, and he's at SUNY Oswego. And then these contributing authors, Kim Dirks, she's at the University of Auckland in New Zealand, and Manjula Sharma is at the University of Sydney in Australia. They have had decades of experience and they've written other things, textbooks and workbooks and things like that. And what they decided to do was to team up with this OpenStax nonprofit organization to basically make you a full-fledged college level textbook that you can access online free of charge. Isn't that sweet of them? Yes, it is. Now, if you'd like to, or if you're able to, or both, right, feel free to make a contribution. They've got, you can add whatever you wish. You can get a print copy if you wish to, although that's not necessary. And if you want to use this book, and this is, we're going to do a lot of reading from here. We're going to do a lot of various activities. You're going to do this a lot, okay? So be prepared. And generally speaking, viewing online is probably what you'll need to do. So you hit the table of contents in this case, for example, and you can see all the different things. Now you can download or print out or order a PDF, okay, or a print copy. It's 1,500 pages long, give or take. It's a big book. It's got pretty much everything, okay? But you see, are we going through 1, 2, 3, 4, 5, 6, like gazillions and gazillions and gazillions of cool facts and formulas and information and stuff like that, and history too. Some of the really good stuff in this book. I want you to be aware of it. We're going to be using this book quite a lot, okay? But it's free, which is nice. So we're not going to quote the book down to light, but I very often will kind of go over through this section, for example, when we're talking about the physics of hearing and sound or something like that. The textbook is very good for that. And so we kind of go down through it. I won't read everything in the textbook, but we'll use it as our guide to understand the kinds of things that are important in the science, right? More important than just the facts in the textbook, though, is the idea, the overarching idea of how physics is done, or how science is done for that matter. And we're going to focus on that a lot over the course of this semester. Indeed, if you take away like 2 or 3 big ideas in this class, all right, and you may even do this again in future classes, you want to take away the idea of what is a science. What is scientific thought and scientific theory? Right? Why are we doing the things that we do? You're going to see a version of this, okay, quite a lot throughout the whole course. The ideas of facts, data, laws of nature, we try to explain them by making educated guesses known as hypotheses. Are they scientific or are they non-scientific? And then can we confirm them? Are we able to falsify them or attempt to falsify them? Are they written in such a way that this cycle can continue? Scientific theories are not guesses. They are a kind of theory that has been confirmed through experimental evidence, through deep thinking, and through all kinds of tests, right? And so I want you to understand this, and then this cycle, when the scientific theory always cycles back, because once you understand how scientific theory works, you build it in to your set of facts, and they expand and they get bigger and they get more interesting. So I want you to think about that as what physics is. It is a fundamental science. It is a way that we take the knowledge of the universe, translate it into things that we can use, and then use them to better our lives. Let me go into that in a little bit more detail here. A lot of times, physics seems like just a whole bunch of like impossible math problems, right? And I have had that experience before too. I also took physics classes, many of them, in fact, probably a whole boatload of them over the years when I was a student. And at all levels, physics was a lot like basically doing a whole bunch of Sudokus, whole bunch of Wordles, whole bunch of crossword puzzles, right? It's basically like, okay, here's something set up, solve this problem. And if you enjoyed it and you solved it quickly, great, wonderful. And if it's like, oh man, what a pain, then it gets annoying, right? What I would say is, work with us. We physics instructors generally have thought a lot about what physics is and physics classes are. And generally speaking, we want you to do those practices. That's like doing the shooting drills. It's like doing batting practice. It's like practicing, every day before performances and so forth. It's the same kind of thing, right? But I know, and we all know, we physics teachers all know, that sometimes it feels a little bit foreign. Why? Because math, right, is not a language that we were all built with to learn how to write down on a piece of paper. We all know how to do math in our heads. In fact, your brain, regardless of how much you love math or how much you love physics, many of you do love math and physics, some of you not so much. But let me explain this, right? And this is serious. This is really a big part of this course and the message that I'd like you all to have from this course and any other future science or math courses, and especially physics courses that you take. Okay. Our brains are doing math all the time. We are doing physics. We are calculating like crazy, but every day. when you're walking down the street, when you're driving a car, when you are planting bushes in the garden, whatever you're doing, you're always doing huge amounts of physics, right? Whether you should how you cook, whether you should hold a pot in a certain way, whether you should take things out of the microwave with or without any kind of finger protection, whether it's hot or cold, whether something is loud or soft, whether you're wearing headphones or whether you wear ear protection or whether you're listening to music or whatever, right? You're always doing physics. You're doing physics all the time. It's just that you're not putting it down on a piece of paper. You're not solving it like you would a Wordle or a Sudoku with set rules and ideas and so forth, right? So that's really what physics class has been traditionally for years and years and years, centuries even, really. Since Galileo and Newton and folks like that first laid down the laws of physics in mathematical form, right? So what we are doing as instructors is pretty much like as interpreters or translators. We're trying to teach you a language like math, right? Or enough of the language of math so that you can read and understand the poetry, the literature, the beauty, right, of our world, of the universe, of our human bodies. So try to take it that way. Think of the math and the physics as a tool, right? Very often you'll be like, oh, if I can't solve the math problems, then I don't know physics. I don't want you to think that. I want you to do your best in the math. Yes, I want you to think of math, think of physics, as I said, as a language with which you are trying to learn the beauty, the literature, the poetry, the stories of the cosmos, of us, of all our lives, right? Think of it that way. And what you'll see is that the math, yes, it could be frustrating, difficult, but that's okay. I mean, I'm not that good at math either, believe it or not. I'm really not. But I practice it a lot, right? Because it's like what I love to do. This physics thing, this astronomy thing. Many of you may know this, but I'm an astrophysicist, an astronomy researcher. Really, I study distant galaxies when they crash into one another, and what happens when the stars form as a result, or a supermassive black hole gets fed material and starts to glow with the power of literally millions of suns. Things like that. It's beautiful and awesome stuff, but I'm not actually natively that good at it. All right. Many of you are probably much better at math natively than me, much better at physics natively, solving these problems than me, but I've just done more practice. So it's my goal to try to give you that kind of practice, but at the same time, really introducing you and explaining and having you understand as best as you can, right? The idea that these laws of nature, these theories of science are the things that help us understand how we work, how the world works, how the universe works is really cool. So try to take that attitude, if you would please. I will do my best also to convey the stuff in that attitude, and so that we can go together and learn this physics for what it truly is. It is the foundation, the scientific foundation of all that we experience, of everything that we do. It's really quite amazing, right? It's beautiful stuff. Now, most of you in this class, all right, not all of you, but most of you are interested in taking this class because it is a step toward a career in the biological sciences, maybe in chemistry or medical positions. Maybe you're interested in being a veterinarian or a medical doctor, a physician, something like that. So very often people will be like, well, what's the point of physics for that? Well, everything's the point of physics for that, right? Why do you think they call it physical therapy? Why do you think they call it physical fitness? Yeah. Why do you think a doctor, a medical doctor, is called a physician? Right? It's physics. And what happens is that physics is so fundamental, it's sometimes buried. And then you don't see the beauty that rises from the physics that comes chemistry or biochemistry or biology, all that complication. It's like that too for other fields like engineering, right? A lot of people like your devices, the cell phones that we all use, the computers, all the things that we use in our houses, the lights, the electrical systems, the cars that we might drive or buses we might ride or airplanes or anything like that. It's all physics, right? But it's been built up from the fundamental principles by engineers, or by other applied scientists that have put things together and created these wonderful machines that are all based on physics. So sometimes you don't see that physics. So this is what we're talking about in this class. We're going to try to illuminate those basics, the very fundamentals. And it might feel a little foreign at first. It might feel a little bit difficult, but it is important and valuable and so useful. And then when you see how it builds into all the other things in our lives, whether it's biology or chemistry or living or whatever, keeping our homes warm, keeping our bodies warm, hearing sounds, seeing things, um, moving things from place to place, including ourselves. That's where the beauty of physics comes in. So go with us on this journey. It's going to be cool. And it's a lot of fun. And yes, there'll be some things that are a little challenging, things that might feel different. Like if I were stepping off an airplane in, say, Taiwan, all right, I speak a little bit of Chinese, so that's good, right? If I get off an airplane in, oh, I don't know, say Kenya, I don't speak Swahili. They speak English pretty well, but if I were actually somewhere where people were speaking a foreign language, I'd have some issues, right? Or if I got off the plane in Warsaw or something like that, I don't speak Polish at all, right? So I would get off the plane and I would be like totally lost. It would feel very disorienting and intimidating, except that I know how to use the tools that are around me, right? I've got a phone, it's got the translate functions, I can talk into it, whatever. I can see stuff, I can scan things, I can do a lot as long as I'm not like vapor locked or intimidated. And I want you to feel that way, okay, throughout all this. And you may find that this physics stuff, this math stuff is super easy. All right, you might, I don't know. It's been a challenge for me. Over the years, it's gotten easier, right? It's because it's something that you do, but it's hard. But hard things, when you do them and you practice them and you do them well, it's very satisfying, especially when it comes to physics. It's a tremendous use. Okay, so let me go back and show you some of the other cool stuff that we're going to be using online. This might be, for example, some of those tools that I was referring to, right? Things that might be a little bit strange at first, but you'll get a chance to use them and you'll have an opportunity to take advantage. We've already talked about the OpenStax physics textbook, right? But these other tabs here, I've shown you some of these things, like I said, they have pretty high production values. These are people who worked really hard to try to help translate or interpret or represent the physics in different ways so that everyone can wind up learning about them. And we're going to be using this quite a bit in our work. Okay, this is the Georgia Public Broadcasting program called Physics in Motion. It's a series of excellent videos and science education stuff that you can learn about physics. For this particular class, it turns out that this physics in motion is just the right level for a lot of the things that we're doing. All right. So introduction to physics, things like physics, significant figures, scientific notation, vectors, scalars, those kinds of things. It's almost like stuff that you should already know, but obviously we're not going to hold you to the fact that you claim to already know it. No, it's not that. Then you have unit 2. What is motion? Describing motion. What is the difference between distance and displacement? The difference between speed and velocity, things like that. And then you're going to hear a lot about kinematic equations. So these are all the things that you're going to be learning about right at the beginning. And so this is extremely useful. And then we talk about forces in this one, so on, momentum and energy. Each of these resources are going to be, like the textbook, not exactly the same order that we're doing it in our class, right? Because what we're trying to do in our class is to show you like why things do the things that they do, and then you practice the things that they do, the why and the how and the things like that all match up. And so it gets pieced together in different ways, but the materials are still there and they're very, very useful. So be prepared to use the Georgia Public Broadcasting Physics in Motion material. And then a couple more materials that we'll wind up using a fair bit. Some of them will be required, but others, I just want to encourage you to explore and see what you want to learn. Okay, one of them is this person's YouTube channel, Diana Cowan. Okay, let me skip my trial for YouTube Premium. Here's the deal with Diana Cowan. Diana Cowan is, I believe she grew up in Hawaii and she loved physics. She thinks physics is awesome. And she wound up going to MIT, got her physics degree, and then she decided that after graduating college, she wanted to devote her career to talking about physics with people. both in a combination of like cool things about physics that aren't necessarily taught in a curriculum, and in producing some physics class material that would help people learn those class things in physics class that explain yet in another way, right, with additional stuff. This is the stuff I was talking about with high production values and so on and so on. Same is true with the physics and motion videos, right? And so there's a whole series that Diana Cowan has created called Diana's Intro Physics Class. And there's a big playlist with lots and lots of different things. You can see the playlist over here. And a lot of these are lined up with, again, other curricula. And we're going to be using them depending on where we are at different times. You're welcome to come take a look at these anytime. And at the points, we will actually also point it out to you specifically, like assign you some of these videos to watch and to work on and to learn some of the things from. Okay, and then finally, this is Crash Course Physics. Many of you almost certainly have done some crash course watching, whether it's crash course history, crash course physics, crash course astronomy, crash course chemistry, crash course, whatever, right? There's a lot of crash course stuff. This is a great series. It, again, is just a little bit off from exactly what we want to do, but it's very, very helpful in how you want to do things. And there's a description. The narrator is Dr. Shini Samara, and she is really good at sort of describing things. And like I said, high production value. So lots of really good sort of cartoon-based examples and photographs and things like that. Okay, those of you who know the Green brothers, John and Hank, you know that they make appearances in the Crash Course series quite often. So you may see excuse me, other YouTube type personalities. Excuse me, hang on just a second. Hold on, I'm gonna drink a little water here. Much better. By the way, this water bottle also, you'll be seeing this water bottle a fair bit in the course. Turns out that water bottles are very useful, especially if they're about 1/5 full. Okay, this one is a little bit more than 1/5 full, but it turns out that 1/5 full bottle, regular size bottle of water is about 100 grams of water. That's 1/10 of a kilogram. And if I drop it 1 meter, okay, then the amount of kinetic energy this object has when it hits my hand is 1 joule. Isn't that cool? Anyway, you'll be seeing that often. The point is, math is everywhere. Physics is everywhere, but it's not the scary, frightening thing that so many people have perceived it to be. I promise you it's not. And is my goal, one of my big goals in the class is to make sure that you don't feel that way. Instead that you feel like, wow, physics is empowering. Physics is excellent. I may not be the best physicist or the best mathematician ever, but it's going to be useful for me and it's going to be meaningful. So I'm going to learn it. And that's what you're going to do. Okay. So that's the purpose of this class. And okay, I'm going to have to give you the second part of this video in a few minutes. I got like 2 minutes to wrap up this part. And so be ready. Okay, so I'm going to tell you right now the first part that you should be aware of about this lecture. And then I'll do part 2 of the lecture in a moment. Okay, here's part 1 of the lecture. Okay, let's go back to this. It has to do with the College Physics OpenStax textbook. All right, the chapter 2. Now, chapter 1, if you want to read it, I would encourage you to read it to get a sense of like an introduction, what it actually means. And you get all these professors, right? Her, their ideas of what physics is, which is always cool and fun to do. And then there's these significant figures and so on. There's just sort of intros. But you need to remind yourself of these ideas right away. Chapter 2, kinematics, okay? Introduction to one-dimensional kinematics and two-dimensional kinematics. These are likely to be review for you. If they're not, that's okay. We are going to be talking about them later throughout the course, and they're going to be used. But I want you to be mentally prepared to start thinking about these things. So you may see in the first assignment, like study guide stuff, I'm going to have you read some of this stuff and remind yourself of some of these things. And we're going to be using this a lot, but I want you to be ready. Okay, kinematics is what we're just starting with right away. When you go to lab, first thing you do is start dropping stuff and knocking stuff back and forth and making calculations about, you know, how fast something is going, how far something's going, how fast it's changing speed, things like that. Okay, nothing scary. Things that you do all the time, whether you're walking or driving or riding or, you know, going up the stairs, going out, you know, this stuff that you're very, very used to. It's just a matter of, again, is it in the language that you're familiar with? Is it in the written alphabet that you're familiar with? Equations are really just sentences with different symbols, right? So these are the kinds of things I want you to go for and be ready for that. Okay, so that's what we're doing. Okay, Okay, I gotta go. But again, thank you. I hope you've been taking notes for this class. Again, it doesn't have to be fancy because, of course, you can rewatch the lecture if you want. Heck, watch it double speed, although I can talk really fast. Might be difficult to do that. That's okay. I don't mind. Whatever works is fine with me. And then I will come back and give you part 2 of the first lecture in a little while. Okay, all right. So if you got study guides, take a look at them. We're going to get it going. Thank you so much. It's really nice to talk to you for the beginning of this class. Physics 116, Lecture 1, Part 1 is now over, and we're going to go to Part 2 very soon. Okay, thank you very much. Talk to you again soon.